Hello everyone, my name is Chukwofili and welcome back to my channel. Now I know it's been a while since I did one of these videos, but hopefully I'll start to get back into my groove. Today we're going to be talking about Workload Identity Federation, but in order to talk about that, let's take a step back and examine how we currently provide access to our Google Cloud resources externally. So if you wanted to provide external access to Google Cloud resources like say Google Cloud Storage, Google Kubernetes Engine, or Google Cloud Run, to an external service like say GitHub Actions, or say Terraform, you typically will go to your Google IAM control center and then create a service account and then generate a service account key while assigning the roles and permissions for which that service account has authorization to cover. Now, that service account key is then what you would configure on your external application, be it your own internal APIs, be it Terraform or Google GitHub or GitHub Actions, as I've mentioned earlier. That is what will provide access to those resources. Now, the challenge here is that those service account keys are like passwords. They are actually passwords. You have to treat them like passwords. And because they don't expire, and lifecycle management for them becomes actually much tough. You have to, it no longer becomes, an access problem, but more like a secrets management problem. Because now, everywhere you've kept those service account keys, you have to make sure you've tightened up production access to those environments. But this also doesn't negate the fact that the platform still has access to those keys. That's like putting your username and password or the password to your banking details on a cloud server. It's almost the same thing. Of course, it's not apples to oranges, but you'll get my drift. So enter Workload Identity Federation. Oh, one more note before we talk about Workload Identity Federation is the only way to actually revoke access to those service account keys is by either going to your IAM portal and deleting the key itself or deleting the service account just outrightly. So enter Workload Identity Federation. Technically, the way it works is that Workload Identity Federation enables application to replace these long-lived service account keys with short-lived access tokens. So you don't have to actually export those keys and then configure them in your external applications. The exchange window is actually quite short. You'd configure your provider settings on your Google Cloud resources and then take some certain parameters from those resources and configure them on your external application, and voila, key exchange or access token creation and exchange is done automatically. Now, they say the proof of the pudding is in the eating, so why don't we jump into a demo? So I've created a new project. I've called it Chuka with Workload Identity Federation for short. Of course, I've also created an artifact registry repository, which is a Docker repository, because for this tutorial, I want to use Cloud Run to demonstrate what I want to do, right? I've also enabled the Cloud Run APIs. As you can see, there's no service running. I have also enabled the compute engine APIs. Okay, I already had that open here, so I have compute engine enabled already. I also have a repository which I have created for this tutorial. It's called Chuka /with. Anyone who wants to follow along or actually try this tutorial out, that's the URL, chuka.with. I'll probably keep it in the description as well. Now, I have a very simple application. So this application is essentially a Node.js application. It's very simple, very straightforward. Depending on whatever language it is that you choose, you should be fine. Now, our goal is to try and get GitHub to deploy this Cloud Run application using Docker. So we need to build a Docker image, we need to push it to artifact registry, and then we need to deploy it to Google Cloud Run. Okay, so I see that there are two scenarios where we need permissions. We need permissions to actually push to Google Artifact Registry, and we need permissions to actually deploy to Cloud Run. All right, now typically before you would go create a service account, and then once you have that service account, you would then add it to GitHub, and then GitHub will be able to do the deploys. But today we don't want any service account, so I'll just go back to my Google Cloud IAM profile, check, make sure there are no service accounts, and just checking most likely the default service accounts that are there. All right, just the default, just one. Okay, so now in order for us to deploy this, I'm just going to do a real quick check, make sure that my application is running. I'll do an npm install. Everything seems to be installing. Npm start, and I will check the app. And yes, the Hello World app runs. See, simple app. Now, I'm going to kill it. I'm also going to try building it with Docker. And the Docker container builds. Now we're going to run it and run the container in question. All right, now if I run this, okay, Hello World works. This is in the Docker container. So now we show that at least locally, it's building and running in our environment. All right, so I'm just going to push this code up. Now, before I push the code up, I just want some things I want to note. I have a CI, GitHub's CI workflow, which is based on a template workflow, which is used for deploying Cloud Run. It's a simple template. So this is where the authentication with Google Cloud happens. This is where the Docker build does happen. And finally, this is where the deploy happens. Okay. The authentication happens. I'm using GitHub Actions actually. So the GitHub Actions, they're all here. If you just go, you'll see the actual, I'm using, or let me put it this way, I'm using an action that is available in the marketplace. So that's what I'm using to just speed up my template. If not, I'd probably have to write everything by hand. So this is the authentication action. It says you should pass in your workload identity provider credentials, or well, not credentials, details, and then your project ID, and it will go try and do the authentication, right? I'm also using the Docker build action and the Docker setup action, the Docker build push action, and the Docker deploy Cloud Run action. Okay. Now notice that the deploy action is set up after authentication. Authentication should be one of the first things you set up because this authentication will be federated. All the rest of the other steps in the action will be able to use it. Okay, so just gonna do a quick git push, and I will go to GitHub to check if my changes are there. All right, code is up to date. Now let me check if my actions actually started to run. Okay, so my first action ran. Clearly there's an issue. Let's see what the issue is. This workflow is invalid, line 14, column 3. Okay, I'm gonna take some time to resolve this and I'll be right back. Okay, so now authentication to Google Cloud is failing. Now remember, I haven't added any permissions yet I have not created my provider. I've not created I've not created any of that. So let's go on and ahead and go do that. So we go to Workload Identity Federation, okay, which is slightly different from Workforce Identity Federation. And what we need to do is create an identity pool and then create an identity provider. But it's going to enable the APIs. I'll probably speed this up. All right, so I'm going to create a pool, OIDC pool, and then I need to create a select a provider. So I'm going to use the default OpenID Connect provider, and I'll call this GitHub. And the issuer URL, as you can see, is token actions, google.com, and that's token actions. All right. I don't need a JW file. We have Google subjects, which the first one, and then attribute actor is equal to assertion actor, and then attribute repository, assertion repository, and then attribute repository owner, assertion repository owner. Okay, I'll go to attribute conditions, add this, and this is the expression, and save, I think. Okay. All right. So now my provider, the pool has been generated and the provider itself has been generated. But let me take a step and explain all of these again. So these are attributes on the Google side that map to the JWT token on the consumer side. And so that's where the attribute mapping happens. So here, Google wants to know who the repository owner is, and you're mapping it that when the token gets decoded, the assertion for the repository owner matches. So the mapping is a one-to-one mapping, and that's how Google knows what information and which information it's supposed to use. The default audience is the default audience of the token, which usually points to the full resource name of the workload identity provider pool, but you could also change it to whatever it is that you want. I'm just going to use the default because that works, right? And that's honestly, that's pretty much it. So I've configured the GitHub provider right now, but then I need to consume it. Now, in order to consume it, there are two things that need to happen. One is I need to actually provide permissions to what it needs. So for now, I would actually just allow this try to rerun the action and see if it works. There's one other point I wanted to make. You could also, do the permissions by using the principal directly, which is this, which means you assign roles and permissions to the principal, or you could actually use a service account so that GitHub will impersonate that service account, and then you can assign roles to that service account. This is where you see the resource name. So this is the full resource name by default. But anyway, that information is going to be needed, and I'll explain it in a bit. So now, how do we provide this information to GitHub? Now, in my templates, if you notice, I have a, okay, I'm going to close my terminal here. So I have my authentication action here. The only two things I need to provide is the project ID and the workload identity provider in this format. So projects, the GCP project number, which is different from the project ID, the location, global, workload identity pool, the GCP workload identity pool name, the provider, and the GCP identity pool provider name. So what would that look like? I've already parameterized this in my template. So here is where I'm passing the information. So the service name here is going to be Hello World. I pre-filled this already, by the way. The GCP project is Chuka With, as I mentioned before. That's the project. I can go to Cloud Overview and you see the project name. Okay. The project number, as you can see, this is the project number, and this is where I get it from. Or, well, oh yeah, project name, project ID. My apologies. You should copy the project ID, and that's what I'm using here. Coincidentally, my project ID and project name are the same. All right. And then the identity pool. I think I used ODIC pool. Let's just check it again. Yes, the name of the pool is ODIC pool. So that's what I used. We'll change that here. And then the identity pool provider name, I think I used GitHub. Yes, GitHub is what I used. The display name is different from the ID, but the ID is what you want. So GitHub is what I used, GitHub, right? And then this is my GCP Google Artifact Registry name, right? And I think I showed that at the beginning of the tutorial, and that is Artifact Registry. Okay, so it's Hello World. So this is where it will push our Docker images. All right, so now that we've configured everything, again, the reason why this is sped up is because I already have a template which has all of the configuration down. If you want to understand it better, just look at the template. It's quite straightforward. I'm going to try and run this again, but I think I made changes. So I'm going to update this. Just say update GitHub. Do a push and do a sync and see if everything works. Fingers crossed. All right. There's nothing like as good as doing everything in life. Okay, it seems like authentication works. So you can see I'm authenticated with Google Cloud. Now I need to set up the G Cloud SDK. And once that's set up, all right, that's set up successfully. Now it's setting up Docker build. That's the next step. These are all the steps. So this was the first step, which was authenticate with Google Cloud. Did you see? First of all, you saw how easy it was to authenticate with Google Cloud. No issues. I already have a credential. Or well, I have access because the credential is going to give you access with a token, which is going to be temporary. All right. And then I'm doing a build and push now. So as expected, I expected that the build and push would fail, but every other step before this worked. Okay. So notice my authenticate with Google Cloud worked. Set up Google Cloud SDK worked. Export the actual URL where I want to push it to, that worked. Set up Docker build, of course. Now authenticate with Google Artifact Registry, that worked. Okay, the credentials were there, everything was there because of this step. But how come we failed our push? I was expecting this. So it says it failed to authorize, and that's because we don't have access to push to Google Artifact Registry. So let's fix that. So I'll just say Google IAM roles. And I think these are all the roles and permissions reference. Yes. And I'm going to find Artifact Registry. Okay, for the purposes of this tutorial, I'm just going to give it repo admin. All right, now it's time to add the permissions for GitHub Actions to be able to push to Artifact Registry, right? So what we need are the things that we need. We need the principal set itself. We need the role we need to add. We need the location of the repository, and we need the project ID. We also need the name of the repo. So this is the syntax. This tripped me up for a bit. So I had to actually take my time to actually compose it. So this just says add IAM policy binding to the Hello World Google Artifact repository in the project Chuka with in the location Europe West 2 with the role Artifact Registry admin to this principal set. Notice that in the principal set, I have the workload the workload identity ID here, and that's it here. The pool is called ODIC pool. Notice I didn't specify the provider name because that is the consumer. And then I have the GitHub repository that is going to be allowed to consume it. This is the repository here. You can see it's Chuka with, right? I could have also specified Chuka Philly, which means any repository coming through will have access to Google Artifact Registry. All right, so let's add this to the command line and let's run it. And now we have added the permissions. So let's go try and see if GitHub Actions will be able to push. Notice that I still haven't provided any service account keys. So it's been able to do a push, and we can check to make sure that it did. So we've gone past one step. Now, if we check here, we see our first Docker image, which was pushed with the actual tag, which should match the commit hash, right? Let me just check the commit hash, which is OD1BOC, OD1BOC. All right, cool. Now, I'm expecting the Cloud Run deployments to fail, of course. Now, and you know why? And that's because, again, we don't have permissions to push to Cloud Run. So what do we do again? We go and add the permissions for Cloud Run. Okay, so it looks like our service deployed successfully. Let's go check. And voila, we have our service container deployed. Okay, so what have we learned? We were able to get our Hello World app deployed without actually having to create a service account key, without having to share anything with GitHub. And you can see that the only things that I specified here are the service name, the project ID, project number, the pool, and the pool provider. Now, some people would say, okay, but well, anyone can specify this in their own repository. True, but because on the credential side for Google Workload Identity Federation, I have specified what I want as my provider attribute condition. So if the repository owner, which means you, the consumer, if you are not Chuka then you won't be able to use my Google resources. This is what prevents anybody else. So yes, you could try to make the request, use all my credentials, use everything, but as long as you don't have access to my repo, then you won't be able to actually make any changes to this project. Of course, I'm going to delete this project once this tutorial is done, but that's how everything just works. So the token is generated and shared with GitHub. GitHub then does have access to then do the resources. And notice that we're using the principle of least privilege. So that makes it easy. This actual GitHub action only has access to do three things: deploy Cloud Run, act as a server account user because of Cloud Run deployments, and finally access to push and pull from the Google artifact repository. Now, of course, I can even do some more security hardening by removing admin and only creating read and write, which reduces the scope depending on how you all individually want to configure your own security preferences. This was just for demonstration and tutorial purposes. So that completes the first half. Now, the second half is using the service account. So when I say using the service account, is using Workload Identity Federation, but using that by impersonating a service account. So you still won't share service account keys. However, it makes it slightly easier for you to just assign permissions to a service account that GitHub Actions will impersonate, or the consumer will impersonate, which is slightly different from actually exporting a service account key in general. Sometimes I like to use that because I'd always have to go through the documentation to figure out the actual syntax for each of these services. I mean, I have the general knowledge, but there's specific differences. For example, with Artifact Registry, you had to provide location, right? Meanwhile, with Cloud Run, I had to the only thing I needed to provide was just the role and the member principal set. And then, it's nuanced. There's one caveat though. You might not be able to use direct Workload Identity Federation for a Firebase or Firebase admin. Any Firebase admin resources, it may not work. The documentation clearly states that. So you probably still need to use service account keys or Workload Identity Federation via service account. But you know what? I'll put an asterisk on that because I still haven't tried. Every time I've done Firebase, I've usually just used service account keys directly. Okay, let's try using the service account, right? But in order to do that, I want to revoke all these permissions. So I've removed all the permissions that we need. I'm sure if we try to run this again, this should fail. And then just run the workflow again and see whether it should fail by default. Okay, now while that workflow has kicked off, it's able to authenticate, but not able to push. All right, so as we said, you can see it's failing now. Okay, so let's go into the next half of the tutorial. Okay, so now we want to configure using the service accounts because everything is failing. The first thing we'll do is let's go create a service account that we want to use. Okay, so we'll go to service accounts. We will call it, let's call it workload. You know what? Just call it with. Just call it with. All right. And we'll create and continue. All right. And then Done. So now we have a service account. We want to attach that service account to our GitHub provider. Okay, so now we want to grant access to using a service account. I've already generated a service account as you saw in the previous step. Now we want to grant access. Grant access uses service account impersonation. You select the service account which you just created. Now use repository and then type, for me it is Chukwuofili and the repository is with, right? So this is the GitHub report. This is the GitHub owner, which is myself, or organization, which could be whatever your organization name is. And this is the actual repository that needs to get access. And then you click on save. Now it might ask you to try to download config. You can dismiss this. You don't need that. All right, go to connected service account. Oh, interesting. Oh, there it is. Okay, so now we know that the attribute repository is with. Now, it does say that if you're using Google Cloud Client libraries to connect to the Google APIs, you need to provide the credentials, and you can do so by downloading this. But yeah, in this case, we aren't using client libraries. We're just using GitHub Actions. It could be Terraform. It could be anything. It could be your own APIs, and you've implemented OIDC. So it's all up to you. So now we've provided access to a service account. But notice that this service account doesn't have any permissions. Let's look at it. So of course, so now I will grant access to the service account, and it was called with. And let's assign a role. Let's call it artifact registry admin. But now I can be more granular. I can do artifact registry reader and then artifact writer. Okay, and then I save. But I also want him to have access to Cloud Run. So I'm going to add another one, and I'll call this Cloud Run. Let's use Cloud Run Developer, and then I'll save this. Okay, so the only thing I now need to do, I've given all the permissions that he needs, and then I'll take the service account name. I'll copy this, and then in my template, which I already have, I will add the service account email, which will come here. Okay, and just make sure that my template has the right service account email. Apologies, I had to comment it out, but yes. And that's the only change that I need to make, at least with this GitHub action. All I need to do is provide the service account here, provide the service account, but notice I'm not still providing any keys. I've configured the service account. It is already linked here. And just check one more time to make sure the connected service accounts are there, and it's there, right? So that's the service account that's linked. And now all we have to do is commit these changes and then core added service accounts. But notice no keys. Now I'm going to do a git push, and our workflow should kick off again. And hopefully this time it should succeed. Now notice I had to remove all the previous permissions just to demonstrate, to demonstrate that it didn't have any permissions anymore. And now we're going to authenticate via a service account. And if you check, the service account is actually included in the action. And now it's going to set up Cloud SDK. And the ultimate test will be if it does a git push. All right, it was able to do a push. Okay, because it has the permissions. And now let's see if it's going to do a new deployment. Of course, it didn't do. It says, oh, I forgot to include service account you impersonator. So let's just add that permission. It's always good to do these things live, because yeah, then you see, how even those of us who create content, what we go through. So I'll say service account user. And I'll save this, and I'll rerun my action. And this should work now, because that permission that is needed is specific to Cloud Run. The service account user is specific to Cloud Run. All right, that deployed. Okay, let's check our Cloud Run services and make sure that the new service is there. And let's see, there should be a new revision. Yes, there's a new revision which was just deployed, and our app is still live and everything's okay. All right, that marks the end of this tutorial. So thanks for watching. I hope this was useful and I hope this helped you. If you have any questions, you have any feedback, please leave us in the comments. I'll be happy to answer any question anyone has. Please don't forget to like and subscribe. Until the next one, bye.